Question 1. So to integrate this, we first got to get it into a suitable format to be able to integrate it. So the 2x to the power of 5 is fine, and the minus 5 at the end is fine, but really this fraction here is complicated to integrate as is, so we're really better off taking the denominator upstairs, if you will. So we're going to be minusing something, but if we take the x cubed upstairs and make it x to the minus 3, we have a quarter of x to the minus 3. So the key first stage is to change this second term into being minus a quarter x to the power of minus 3. Now be careful, quite often people forget to use a quarter, and remember this is minusing a quarter of 1 over x to the power of 3. So that's the key step. Now from then onwards it's fairly straightforward. You just work your way through integrating each term in turn. So I've put in this middle stage where I just simply followed the two steps of integrating. So step 1, increase the power by 1. So x to the 5 becomes x to the 6, and step 2, divide by this new power, so I'm dividing by the 6. Secondly here, step 1, increase the power by 1, so minus 3 becomes minus 2, and step 2, divide by this revised power of minus 2, and then for this third term, when we're integrating, minus 5 becomes minus 5x, and then don't forget to add the plus c, adding on the unknown constant. And then finally, given we've got to give each term in its simplest form, I've simplified 2 over 6 to being 1 over 3, and I've simplified a minus a quarter being divided by minus 2 to being plus an eighth. So that's plus an eighth x to the minus 2 minus 5c plus c. Question 2. So let's first of all write this function not using the square root signs but using indices. So the square root of x is x to the half, and the square root of x is obviously x to the half, but taking this from the denominator to the numerator, this becomes x to the minus a half. So this second term becomes plus 4x to the minus a half plus 4. So now we're going to differentiate this. So remember how we differentiate. We multiply by the current power, then reduce the power by 1. So we multiply by the half and reduce the power by 1 to minus a half. We multiply by minus a half, so that becomes minus 2. And we reduce the power by 1, so that becomes minus 3 over 2. And then differential of plus 4 is 0. So if we then, so that's it differentiated, but I really want to put it back into this sort of format. So it's going to make it easier for me to substitute x into it. So x to the minus a half is dividing by the square root of x. And x to the minus 3 over 2 is dividing by the square root of x being cubed. So I now want to substitute into the differential when x equals 8. So I'm popping 8 into this differential. So the square root of 8 is the square root of 4 times 2, which is 2 times root 2. So, so we can replace the square root of 8 by 2 root 2. And now for this one, I've just done as a side working. This is quite complicated. Think about what the square root of 8 all cubed is. So I've done that up here. The square root of 8 all cubed is the same thing as 2 root 2 all cubed, because 2 root 2 is what root 8 is. So that's the same thing as 2 cubed and root 2 times root 2 cubed. 2 cubed is 8, and root 2 cubed being root 2 times root 2 times root 2. Well, root 2 times root 2 is 2. So times root 2 again is 2 root 2. So that gives us 16 root 2. So moving on, obviously 2 lots of 2 is 4. So we've got 1 over 4 lots of root 2 minus a simplified version of this. I've just divided through by 2 of 1 lot of 8 root 2. Or just dividing top and bottom by 2 here. So how do I take away fractions? I need to have a common denominator. So I've chosen to multiply top and bottom of this first term by 2. So I'm replacing 1 over 4 root 2 with 2 over 8 root 2. I've now got the common denominator, so I can take away 2 take away 1 is 1, so that's one lot of 8 over root 2. Now I need to rationalise this. I've got to give my final answer in the format of a root 2. So how do we rationalise this? We choose to multiply top and bottom by the denominator. We could do 8 root 2 over times 8 root 2, but obviously the 8's just cancel. So I've just taken the root 2 from the denominator. So that gives me top times top, bottom times bottom. One lot of root 2 is root 2. Root 2 times root 2 is 2. 2 8s is 16. So I'm left with root 2 over 16. So to write this in this format here, that is a 16th of root 2. Question 3. So we've been asked to write down expressions for A2 and A3 in terms of K, giving your answer in their simplest form. So quite simply, the next term is K multiplied by the previous term, add 1, and then all of that divided by the previous term. So A to the n is the previous term, A to the n plus 1 is the current term. So for A to the 2, so our second term, we need to do K multiplied by the previous term, A1, which is 1, plus 1, all divided by the previous term, which was 1. So A2 is K multiplied by 1 plus 1 all over 1, which is 2K. Now our third term, A3, comprises K multiplied by our previous term, which was 2K, plus 1, divided by our previous term, which was 2K. Now these two K's cancel out, giving us 2K plus 1 all over 2. Now for part B, find an exact value for K given that this. Now this sigma here means that our first term plus our second term plus our third term added together equal term. So our first term A1 of 1 plus our second term A2 of 2K plus our third term A3 being 2K plus 1 over 2, those three added together equal 10. So to undo this dividing by 2, I've chosen to multiply through by 2. So double this, double this, double this, double this. So I get 2 plus 4K plus 2K plus 1, because I'm dividing by 2, times by 2, equals 20. 10 times 2. So gather up our like terms. We get 6K plus 3 equaling 20. Take away 3 from both sides. And dividing by 6, we get K equaling 17 over 6. Question 4. So I've included the given arithmetic series formulae here because we're going to be using this in this question. So a company makes 140 bikes each week, plans to increase its production by D each week, so it's adding on another D each week, and so on. So basically, then we've been told it's producing 206 in week 12. So let's try and establish the pattern. So in week 1, we know we're producing 140. In week 2, we're producing 140 plus D, as it says in the question. And in week 3, 140 plus 2D, and so on. And we need, and we're told also that after week 12, it's producing, is making 206 bikes. Now, following this pattern, we can see that the number of Ds is one less than which week we're dealing with. So week 12 is going to be 140 plus 11D, and then we're told in week 12 we're making 206 bikes. So 140 plus 11D must equal 206. So we've constructed an equation to solve. So take away 140 from both sides, divide by 11, we get D being 6. Now we're told then that after week 12, the company plans to carry on making 206 bikes each week. Find the total number of bikes we'll be making the first year, in the first 52 weeks. Okay, so for the first 12 weeks, we're following this arithmetic sequence where we're going up by 6 bikes each week. Okay, so we can use either of these two formulae here, the summing formulae, to work out how many bikes we would have sold in the first 12 weeks. Now, given we know the last term is 206, I think using this one here is just easier. So N is the number of weeks, which is 12. A is the first term, which is 140, and L is the last term in this 12 weeks, which is 206. So substituting those in to this formula, we can see that the number of bikes we sell in the first 12 weeks is 2076. Now, for the rest of the year, we carry on making 206 a week. So how many weeks is it for the rest of the year? Well, that's from weeks 13 to 52 inclusive. Now, that's 40 weeks. For the following 40 weeks, we carry on making 206 a week. So that's another 8240 bikes sold or made. So how many altogether are for the first year? It's going to be the 2076 from the first 12 weeks added together with the 8240 for the final 40 weeks of the year, giving us a final answer of 10316. Question 5. So part A, we're being asked just to rewrite this in the completing the square format. So really the key learning point here is that we need to include as a half of what the coefficient of x is. So half of minus 8 is minus 4. So that's our starting point, x minus 4. Now you've then got a picture in your mind what x minus 4 all squared would give us. And that will be x squared minus 8x plus 16. Now at this point I'm just trying to equate through to x squared minus 8x. So my x minus 4 all squared is throwing out an additional plus 16. So to back this out, I need to include a minus 16. So just so we're clear, x minus 4 all squared gives us x squared minus 8x plus 16. So if I then take away a further 16, I'm left with x squared minus 8x. And then the plus 19 and the plus 19 remain. And then just tidying this up, minus 16 add 19 is plus 3. So our final answer is this for part A. Now for part B, sketch the graph of C showing the coordinates of point P and the coordinates of point Q. Okay, and we know that P is where it crosses the y-axis and Q is the minimum point. Now the benefit of completing the square is that it shows us where the minimum point is. Okay, so just from this, in order to minimize the y value, we need to minimize this first term. To minimize anything being squared, it has to be 0. So in short, x needs to be 4, because 4 minus 4 is nothing. Nothing squared is obviously nothing. So our f of x is going to be minimized when x is 4. X is 4. Now what y value does that give us? Well, that's going to give us 0 with our first term and plus 3. So it's going to give us a y value of 3. So our minimum point is 4, 3. In short, our minimum point is always going to have an x coordinate opposite to this number here. So not minus 4 plus 4, and a y coordinate of this term here, the plus 3. Now we also need to find out P where it crosses the y-axis. The curve crosses the y-axis when x equals 0. So substituting 0 into the function, 0 minus 0 plus 19 is 19. So that's where P is. And given this quadratic has got a positive x squared, we know it's going to be a positive parabola, a smiley face shape. So that's how our graph is going to look. Now for part C, we're being asked to find the distance PQ, writing our answer as a simplified surd. So a quick sketch to help us gather our thoughts. P's at 0.19, Q's at 4.3. So using Pythagoras, I've just popped in a right angled triangle here. So our base, our x value is going from 0 to 4, which is 4. Our height, our y values are going from 3 to 19, which is 16. So the length PQ, using Pythagoras, PQ squared equals 4 squared plus 16 squared, which is 272. So PQ is going to be the square root of 272, which is the square root of 16 times the square root of 17, which is 4 root 17. Question 6. So for part A, now y is equaling to the power of x. So this is our starting point. So let's think about it. 2 to the power of 2x plus 1 is the same thing as 2 to the 2x all squared, because that's what the 2 to the 2x is, times 2 to the 1. So that's, you've really got to concentrate to spot this. And it's easier almost to see it backwards. When we've got 2 to the power of 1 times 2 to the 2x, when we multiply, we add the powers. So that's how we're going to be getting the 2x plus 1. And then similarly, 2 to the 2x is the same thing as 2 to the 2 all to the power of x, or equally 2 to the power of x all to the 2. So this term here becomes this here. This one is more straightforward. 2 to the x is just being substituted in. It's just being replaced. It just remains the same, and this remains the same. So it's all about understanding getting from 2 to the 2x plus 1 to this being 2 to the 1 times 2 to the x all to the 2. Now, once we've got this far, it's simple because we're just substituting in y in place of the 2x, 2 to the power of x. So that's what we had to show. Now, for part B, we're being asked to solve this equaling 0. So let's just solve the, it's in y format, so we've got to solve this equaling 0 to start with. So we've got a quadratic to solve where the coefficient of y squared is not 1. So remember the process here. We're looking for two magic numbers that multiply to make the 2 times 8, which is 16. But at the same time, these two magic numbers add to make the coefficient of y. They add to make minus 17. So which two magic numbers do that? That's minus 1 and minus 16. Minus 1 times minus 16 is 16. And minus 1 add minus 16 is minus 17. So having got our two magic numbers, we basically rewrite this from 3 terms to 4 terms on the left. So we split the minus 17y into minus y and minus 16y. Doesn't matter which way around you've done it, I've chosen to do it this way. So then, having moved to it being 4 terms, you then fully factorise the opening 2 terms. So we're going to fully factorise the 2y squared minus 16y. So that's 2y multiplied by y minus 8. We then fully factorise the third and the fourth term, bearing in mind we want the bracket to become repeated. So that becomes minus 1, y minus 8. Then our next step, our final answer, our pair of brackets comprises the repeated bracket, the y minus 8, and the two components outside the completed bracket. So that's the 2y minus 1. So this is how we factorise this, rather than just doing it by trial and error. So given we've got this far, then our two solutions are whatever makes each of these brackets equal to 0 independently. So here y would have to be a half, and here y would have to be 8. Now that's obviously solving for y. We need to solve for x. So we're saying y equals a half and y equals 8. So 2 to the power of x equals a half, or 2 to the power of x equals 8. So looking at 2 to the power of x equaling a half, first of all, this is when our x would have to be minus 1, because 2 to the power of minus 1 is a half. And here, what would x have to be here? Well, x would have to be 3, because 2 cubed equals 8. Question 7. So we've got to find the equation of the tangent to C at P. Now obviously a tangent is a straight line, so we've got to find an equation of a straight line. So we're going to be using the formula y minus y1 equals mx minus x1. So we need to know two things. We need to know a point on the line. Well, we've got that. We've got the point P is on the tangent. So we know x1 is 4 and y1 is minus 8. x1 is minus 4, y1 is minus 8. So what else do we need? We need to know the gradient of the tangent, the gradient of the line. So that's where the differential comes into place. This differential allows us to work out the gradient of the tangent at any place on the curve. We need to find it out at P when x is 4, so we're just going to substitute 4 into this differential. So 6 minus 5 lots of 4 squared over the square root of 4, which I've done down here, giving us a gradient of minus 7. So popping that into our y minus y1 formula, we get this. I've then multiplied out the bracket on the right-hand side, minus 7x and plus 28. Remember, minus 7 times minus 4 is plus 28. And on the left, y minusing a minus 8 is y plus 8, giving us this here. And then we need to give our final answer in the form y equals mx plus c. So I've just taken 8 from both sides. to give me a final answer for part A of y equals minus 7x plus 20. Now for part B, I've got to find the f of x in its simplest form, so we're going to need to integrate the differential. So first things first, let's get the differential in a fit state to integrate. So I'm popping both these terms over the square root of x, so both of these over x to the half. So first of all, that gives me 6x to the minus half, and then secondly, minus 5x squared over x to the half is minus 5x to the 3 over the 2, because we're taking away the powers. 2 take away a half is 1.5. So this now puts the differential in a fit state to integrate, so I'm now just going to work along and integrate it term by term. So we're going to, so 30 becomes 30x. And remember, to integrate, we add 1 to the power and then divide by the revised power. So this power becomes a half, once we've added 1, and then we're dividing by the half. And this becomes 5 over 2 once we've added 1, and we divide by 5 over 2. And don't forget our constant c. So tidying that up, 6 divided by a half is 12, and minus 5 divided by 2.5 is minus 2. So that gives me this. Now, there's going to be a couple of marks going for finding out what c is. In order to do that, we're going to substitute in a point on the line, which is 4 minus 8. So we know when x is 4, y is minus 8. So I'm substituting 4 in where x is, and minus 8 where f of x where y is. So that's minus 8 equals that there. Then working through each term, we've got 120. This is 24. Square root of 4 is 2. 2 times is 24. And 4 square rooted is 2. 2 to the power of 5 is 32. 32 times minus 2 is minus 64. And then plus c. So simplifying that down, I get c being minus 88. So my final answer is this function that I've written up here, but replacing the plus c with minus 88. And I've done that down here. Question 8. So for part A, we've got to find an equation for this line L2 going down here. Okay, so we're going to need to know two things. We're going to need to know a point on the line, might as well be P, and we're going to need to know the gradient of L2. Okay, so let's look at each of those in turn. So first things first, let's try and find the coordinates for this point P. Now we're told in the question that the point P with x coordinate 5 lies on L1, so we know this value here is 5. So to work out the y value, we're just going to substitute 5 into the equation for the L1 curve. Okay, so first things first, this is the equation for the L1 curve, 5y equals 4x plus 10. I'm just choosing to divide through by 5 to put it into y equals format. So dividing this through by 5, I get y equals 4/5 x plus 2, which I've done over here. So substituting my x value of 5 into this curve, when x is 5, I get 4/5 of 5, which is 4. 4 plus 2 is 6. So my y coordinate here is 6. So when I'm going to be using my y minus y1 equals mx minus x1 formula, my point on my line P2 is P, which is x being 5, y being 6. So x1 being 5, y1 being 6. So the second thing I'm going to need to know is the gradient of L2. Now, in order to work that out, I'm going to start off by working out the gradient of L1, which I know already because I've turned my L1 equation into y equals mx plus c format. So I already know the gradient of L1 is 4/5. Now, L2 is perpendicular to L1. So to work out its gradient, I just flip this 4/5 over to 5 over 4 and change the sign. So the gradient of L2 is minus 5 over 4. So I can pop that into my y minus y1 formula, and I know everything I need to know now. I know the gradient, minus 5 over 4, and I know a point on the line, P, 5, 6. So here we go, that's the equation of the line. Now I'm going to need to give my answer in this ax plus by plus c equals 0 integer format. So I really want to undo this quarter that's dividing by 4. So at this point, I'm going to choose to multiply both sides through by 4. So multiplying both terms on the left, I get 4y minus 24. And multiplying on the right, that really undoes the dividing by 4. So I'm left with minus 5 to be multiplied by x minus 5. And doing that claw, that's minus 5x and plus 25. Remember, minus 5 times minus 5 is plus 25. So that takes me to this line, and then taking everything over to the left-hand side, I get 5x plus 4y minus 49 equals 0. Now for part B, I've got to calculate the area of the triangle SPT. Now to do that, I'm going to work out the length of its base from S to T and multiply that by its perpendicular height, which is 6, and then half this. So half times base times perpendicular height. So all I need to work out is the length of the base, so I'm going to have to work out the coordinates for S and the coordinates of T to do that. Now S lies on the L1 graph, y equals 4/5 x plus 2, and it's when y equals 0. So I can set this to equaling 0, 4/5 x plus 2 equaling 0. So taking away 2 from both sides and multiplying by 5 divided by 4, I get x being minus 5 over 2. So this S is minus 5 over 2. Now T lies on L2, and again is when y equals 0. We've got nothing up the stairs. So let's set our L2 curve to when y equals 0. So here's my L2 curve, and I'm looking when y equals 0. So I'm substituting 0 into here. So 5x plus 4 lots of 0 minus 49 is 0. Working through that, I get my x value being 49 over 5. So the length from S to T is going to be 5 over 2 plus 49 over 5. And I've just done that down here. When we're adding fractions, we've got to have a common denominator. So that gives me 123 over 10, which is 12.3. So I know my base length is 12.3. The perpendicular height is 6. So the area of the triangle is half times 12.3 times 6, which is 3 times 12.3, which is 36.9. Question 9. So part A, we'll just draw these two graphs in separate axes. So this first one's clearly a straight line graph. It's got minus m, so it's got it's a negative gradient, so it's going downwards left to right, but it's crossing the y-axis at a positive value. So that graph's going to look like that, going downwards but crossing at a positive c value. And then for part 2, well, this is just the reciprocal graph shifted up 5 places. So whereas we'd normally have the asymptotes being the x and the y-axis if we were plotting y equals 1 over x, this whole graph is shifted 5 upwards. So our asymptote, our horizontal asymptote, is on the line y equals 5. And just pop the lines in like this. Okay, so for part B, given that the straight line meets the curve at 2 distinct points, we've got to show something. Now, the second the question starts talking about the number of times 2 curves across, then we're talking about the discriminant, b squared minus 4ac. So while we've got 2 solutions, b squared minus 4ac is going to be greater than 0. Remember, if we had one repeated solution, it would equal 0, and no solutions, it would be less than 0. So we know b squared minus 4ac has got to be greater than 0. So let's set our 2 graphs equal to each other, so our straight line equaling our reciprocal graph. And let's choose to undo this dividing by x to multiply through by x. So we get minus 3x squared plus cx equals 1 plus 5x. Taking this all to the left-hand side and setting equal to 0, we get this discriminant here. We get this graph here. So what have I done? In fact, I've taken it all to the right-hand side, excuse me. So I've taken it all to the right-hand side. So I've got 3x squared plus 5 minus cx plus 1 equals 0. So for our discriminant purposes, our a is 3, our b is 5 minus c, and our c is plus 1. So substituting that into this, we get this. And then obviously 4 times 3 times 1 is our minus 12. So 5 minus c squared is greater than 12. Now for part C, hence find the range of possible values for C. So first things first, I'm just going to do a little sketch to help me gather my thoughts. Now 5 minus c all squared greater than 12 is a positive parabola. I've just done that down here in red to show you. So I've actually got a smiley face graph crossing at, now where does the graph cross? So let's solve this equaling to 0. 5 minus c all squared equaling 12. Let's solve this. So square rooting both sides, you get 5 minus c equals plus or minus root 12. So c equals 5 plus or minus root 12. So that's crossing here and here. Both of them are positive values. Now I'm looking for where this is greater than 0, so above the x-axis, so this stretch of points here and this stretch of points here. Now just be careful, this stretch of points here is fair enough, that's just c is greater than 5 plus root 12, but this set of points here you've got is less than 5 minus root 12, but remember c is a positive constant, so you've also got to include that c is greater than 0. This stretch of points here, c is greater than 0, but also less than 5 minus root 12. Question 10. So before I move on to part A, I'm just going to try and find what these 3 points are on the graph. So where the graph is equaling 0 on the x-axis and where it's crossing the y-axis. So first things first, when x equals 0, what does y equal? So substituting 0 into the function, we get two lots of 0 is 0. 0 minus 5 is minus 5. Minus 5 squared is 25. And then 25 times 0 plus 3 is 25 times 3, which is 75. So that point there crosses the y-axis at 75. Now with regard to the curve when y is equaling 0, so where it crosses the or touches the x-axis, we're setting this equal to 0. So what makes each of these brackets in turn 0? Well, 5 over 2, 2.5 makes this bracket 0, so that value there is 5 over 2, and minus 3 is where it crosses over there. Now, for part, that's going to be helpful for moving on to part A. So we've got the curve with equation f of x minus k passing to the origin, find the value of constant k. So the graph has been shifted down such that this point here is now here. So how far down has the graph been shifted? What value must k be? The graph has been shifted down 75. So 75. Now similarly, we're now told for part 2 there's a minimum point at the origin, so the curve has shifted 5 over 2 to the left for this point to now be at the origin. So remember, inside the function the sign goes the opposite way to what you'd expect, so a shift of 5 over 2 to the left comes about with c being plus 5 over 2. Now for part B, we're being asked to show that the differential equals this. So first things first, let's multiply out the curve, getting it in a fit state to differentiate. So 2x minus 5 all squared is 2x minus 5 times 2x minus 5, which is 4x squared minus 20x plus 25. Multiply that by x plus 3. So I've multiplied each of the 3 terms by x, and then each of the 3 terms by 3 gave me this. Then gathering up like terms, I got the function of x being this. So we can now differentiate this. Remember, to differentiate, you multiply by the current power and then reduce the power by 1. So 12x squared minus 16x minus 35, as we had to show. Now for part C, we've been told that the gradient of the curve at A is equal to the gradient of the curve at B, and A has x coordinate of plus 3. So there's 2.5, so this is about plus 3. So taking the gradient of the curve there at point A, and just for the purposes of the diagram, that gradient looks about the same, so I'm making point B be about there. So now I've got to find the x coordinate of B over here, so it's going to be some negative value. So first things first, I know that the gradient at 3 is something. So let's go and find out what the gradient is when x equals 3 by substituting 3 into the differential. So I'm substituting 3 into this, which is this, which then becomes 108 minus 48 minus 35 equals 25. So the gradient of the curve here is 25, and so it will be over here. So just making the differential now equal to 25, let's find the two values for x where the differential is 25. I know one of them is going to be 3, but what's the other one going to be? So I'm now setting the differential to being equal to 25. So taking away 25 away from both sides, that gives me a quadratic equation to solve. I've then divided through by 4, and I've then factorised, giving me x minus 3 and 3x plus 5. So my two values for x are plus 3, which I already knew. That's the value for A. But also for B, it's what value of x makes this bracket 0, and that's minus 5 over 3.